Dr. Park, first, one thing you talk about is the difference between, well, that we have two methods of defining age in our body. One's a chronological from the date we were born, and then the other one is the age of our body. Can you talk about how they differ?
Well, I mean, chronologically, we measure in years, right? So, but that's pretty much useless. And, you know, it's a source of incredible anxiety for people. And what's a little more reliable is the telomere age. So people say age is a number. Well, that's not really true. But telomeres, you can objectively measure how much fuse or wick you have on the ends of your chromosomes. And as we get older, they shorten. But, you know, the reason I say the number, the age doesn't matter is because, you know, you have people who lived, you know, 900 years in the Bible. You know, if you believe in that. You have kids that live 13 years and die of old age. So, and likewise with cars, you know, you don't drive your car off the lot and expect it to last 2.4 million miles. But there's a gentleman who's driven his Volvo for 2.4 million miles. So, you know, it doesn't matter as long as you do the maintenance and the repair. So I'm looking at a time when we can be 100, 200, 300, no problem, as long as you do the maintenance and repair.
You mentioned telomeres. Talk about those a little bit and what they are and their role in our aging.
Right. So it's not just us. It's plants, animals, fungi. Anything that's more complicated than a single-cell bacterium needs caps at the ends of their chromosomes.
Okay.
So they're like two strands running in the end, and the ends have to be capped. Otherwise, they'll fall apart like shoelaces. So when you are fertilized as an egg, the whole thing gets reset to the endowment of 15,000 in humans, right? So every time a cell divides, they shorten by about 50 to 100. But luckily, there are special cells called stem cells, which function like queen bees, and they're able to actively lengthen them throughout your life. So the telomeres will erode with time, but that's okay, because you don't want all the drone bees, the honey bees, the worker bees to live. You just want the queens to take care of themselves. It's actually a really good analogy because queen bees will live years, whereas her little clones, her drones, will only live months. So throughout our bodies, we're just trying to save the stem cells. So telomeres are actively lengthened by an enzyme called telomerase, which every single plant animal has only in their stem cells, and it's able to prevent that shortening in all the routine run-of-the-mill cells.
Explain the stem cells that we have in our body then right now, the ones you're talking about. Because when we think of stem cells, we think of the taboo, the embryonic, and the injectable kind. So talk about what the ones you're talking about.
Well, you know, that whole thing about stem cells was kind of a distraction. It injected a lot of heat into a debate and not much light. So at the basic level, stem cell has two characteristics. One, it can immortalize itself, like we talked about, using that 2009 Nobel Prize was awarded for telomerase, and it's an enzyme that lengthens the ends, gives you more DNA, right? Keeps the wick growing so the wick doesn't burn out. But the other characteristic of a stem cell is that it divides asymmetrically, meaning it doesn't make two daughters, it makes one other mother and a daughter, right? So it makes a perfect copy of itself, and then the other one is a less perfect daughter. So it can run off copies. That's what a stem cell. But it's on a continuum. Stem cells can have various degrees of stemness. So like a fertilized egg can become, and does become, all cell types. Every time you differentiate into different layers like endodermic, these are technical things, but every time you go farther down the line in differentiation, you lose the potential to become all kinds of cells, and you lose some of that immortality also.